All right, test 2, section 3. It's going to start off here with a fairly straightforward algebra problem. They're giving you an equation 5x plus 6 equals 10. Now, what you need to be aware of, you're not just solving for x, you're actually taking that x value and you're plugging it into this equation or this expression and seeing what it equals. So make sure you solve for x, you know you're not done. So here we're going to solve this for x, so we're going to subtract 6 from both sides. So when you do that, you're going to get 5x equals 4. And then you divide by 5. So x in this case is 4/5. So once you get that answer, you need to make sure you don't pick that as an answer. If it was, it's not. But if it was an answer choice, be aware not to pick it because, well, it's wrong. What we want to do is we want to get 10x plus 3. So I'm going to take this number right here, and I'm going to plug it into the expression 10x plus 3. So I'm going to go 10 times 4/5. Be aware you do not have a calculator on these. So 10 times 4/5 plus 3. When you multiply, you need to be aware that you can cross cancel. So here I got 10 and 5. That's 10 divided by 5, which is 2. So that's going to be 2 here. So I'm going to have 2 over 1 times, and that's a 1 when you cancel it, times 4 over 1, which is 8. So I have 8 plus 3, which in this case is going to be 11. So that's going to be your answer for number 1. 11 is C. So pick C for number 1. Number 2, they want you to solve this system of equations. It's pretty straightforward, just says solve it. So we can do that. So here we go. Which of the following satisfies that system? So in this case, you know, it doesn't matter. You'll notice once you solve for x typically, or y, doesn't matter, usually there's only one answer that actually matches what you have, so you normally don't even have to solve for both variables, which is great. If you have to, so what, we can do that. But anyway, I'm going to take a look at this, and I have a choice between elimination and substitution. I'm just going to pick one and go with it. I'm going to use elimination on this problem. So elimination will work like this. I'm going to take this equation, I'm going to multiply this equation by 2. And the reason I'm doing that, I want to eliminate the y, and I'm going to be able to do that using this method. So I'm going to have 2x plus 2y for my first equation equals 0. On bottom, it doesn't change at all. So again, all I've done is I've taken this top equation, I've multiplied it by 2. The reason why I multiplied it by 2 is now these coefficients, when I add these two equations together, are going to eliminate. So these are going to be added. Again, you have the choice of adding or subtracting based on what makes the coefficients eliminate. So if you add, those cross out. 2 plus 3 becomes 5x. 0 plus 10 is 10. So 5 times 2 is 10, so x is equal to 2. Now instead of plugging in for y, which you can do, it's negative 2, you want to look at your answer choices. Notice the only one that has an x equals 2 in it is B. Usually you will get one answer choice only. So that's why I like to just go ahead and check. So this one's going to be B because that's the only one that has a 2 for x plugged in for it. So that's going to be number 2. Number 3 is really just asking you to interpret. So we want to pay attention to the types of words that are used. But before I even start, I'm kind of looking at this as a variation of, but still, a slope-intercept form type expression. So I think of this, this is my y-intercept, so my initial value. And then this here, somewhere, one of these is probably going to be some sort of, I mean, there's two variables, but it's a rate. It has just two different things in it, but this is my rate. And I know that's my general form of a slope of a line for slope-intercept form. So I'm thinking that before I even start the problem. But we want to kind of pay attention in this problem of what these things represent. So we get a landscape company estimates the price of a job in dollars using this expression. So here, they're giving you the expression, that's great, but I need to know what these variables are. So N is the number of landscapers. So N equals my number of landscapers. And then next they say H is the total number of hours a job will take. So H is the total hours. And again, you don't have to write that down. I mean, I would just use my pen and circle it in the problem. I just don't have that option here. So that's what those variables represent. You know, H is the total number of hours it will take using N landscapers. Which of the following is the best interpretation of the number 12? Well, I know 12, it's part of my rate. So I'm looking for words like, you know, each or per, something like that. because again, it is a rate. So answers that say the word each or per would be like A and B. A says the word per, B says the word each, but you want to know how it's being used. So in this case, if you look, answer choice A says the company charges $12 per hour. So again, here's the total number of hours. So they're going to charge $12 per hour. This is just how many landscapers they use. But they are charging $12 per hour. That does make sense because that's part of 12 times H is going to be that part of the rate. And they do that for each landscaper. And that's where it kind of brings in this next part, that word each. This is using both those words, the per and the each, because they're representing both rates. So we have $12 per hour, so 12 times H for each landscaper. So that's going to represent the N as well. So again, look for those words each or per, and there's two things being multiplied here, so we use those words twice. So in this case, answer choice A is the one that does that appropriately. So your answer for 3 is A. So that's number 3. Moving on to number 4. So on this one, I can see by looking at this, I have what I would call a perfect square. You may not recognize it right away, but some clues that I usually tell people to look for on perfect squares. First off, the perfect square equation is x plus y quantity squared. Now that's going to equal x squared plus 2xy plus y squared. Now the thing that I usually look for is perfect squares at the beginning and at the end of that expression, and that's what I have here. Now notice these are to the 4th, but they're still perfect squares. So I have that situation here. So I would look to see if this is going to be a perfect square, make sure it matches it. They do test our special factors, including difference of squares, which I think shows up in this test as well. So make sure you are comfortable with perfect squares and difference of squares factors. So in this one, they say which of the following is equivalent to the expression. Again, I can already tell perfect square is probably what I'm going to look for here. So when you factor this using this factoring rule, I can even just factor it just by understanding, hey, I'm going to have a perfect square. So I'm going to have, if this is x squared, this is going to be x, and if this is y squared, this last term is going to be y. So this is going to be 3a squared and 3a squared, because if you multiply those together, you get 9a to the 4th, which means my last terms, that's going to be 2b squared and 2b squared. And if you want to get a positive 12, well, notice that'd be 6 and 6. I'd have to make sure these are both plus. So this is a perfect square. It does work, and you just know to just go test it right away. So this is 3a squared plus 2b squared quantity squared. So we're looking for the answer choice that states that, which is answer choice A. So that's going to be number 4. So next up, we have number 5. So in this one, they're asking you to solve that equation. Solve for the value of k. So they want you to solve for k. They're giving you x. So in this case, I'm just going to go ahead and plug in 7 right here. So I'm going to have the square root of 2k squared plus 17. Now again, what I'm doing is I'm plugging in a minus 7 right here. So I'm going to move that to the other side and set this equal to 7. So now I'm just going to solve this. Now that I move this over, I'm going to solve for k. So I'm going to square both sides. So when you square this side and this side, you're going to get 2k squared plus 17 equals 49. And you now have a quadratic. Now with a quadratic, you want to set it equal to 0. So I'm going to set this equal to 0. Or actually, I won't even do that because there's only one quadratic term here. So I'm just going to solve for k. I'm going to use what's called the square root method, where I just solve for k and I square root both sides. So I'm going to subtract 17 from both sides. I'll do that first. So that's going to give me 2k squared equals, and that's going to be 32. And come up here, I'm going to divide both sides by 2. So k squared is equal to 16. And when you square root both sides, you do get plus or minus 4. Remember, when you I can't talk right, but when you square root, you have a positive and a negative answer. Now in this case, they're telling you k is positive, so we're not going to include the negative. We're only going to include the positive answer. So k is equal to 4, which is C. and that is number 5. Keep it moving. Number 6 gives you, looks like we got some lines. When you look at the picture, they look parallel. And I'm not going to tell you to assume they're parallel, but that should be something that you should be at least looking for, seeing if they have some information to tell you that they are. Because if the lines are parallel, we know the slopes are equal. So in this case, they are telling you they're parallel. And again, if they try to disguise that or hide it, then make sure you're still at least looking for that if they look parallel to you. So when they say they're parallel, that means these slopes are the same. So remember, slope, in this case, if you have a graph, we're going to think rise over run. And again, it's because I have a graph, I'm thinking rise over run. So I'm thinking, well, the line that I do have, I can tell the rise goes from 0 to 2. So the rise is 2. And in this case, the run is 5. So I know the slope of this line is 2/5. So this line, I know my rise is going to be 4. And my run, well, it goes from 0 to p. So that run is p. So I have rise over run equals rise over run because they're parallel. So I know the slopes are the same. So in this case, I'm going to say 2/5 is equal to 4 over p. And again, rise over run equals rise over run. The slope equals the slope. The slopes are the same. So this is a proportion. I'm going to solve using the cross product properties. I'm going to multiply across here. That gives me 2p. Multiply across here. That gives you 20. So p is equal to 10. In this case, 10 is D, so your answer choice here is going to be D for number 6. So next up, we have number 7. So after that, I get my colors right. Number 7, we have what looks like a really crazy problem. It's just some exponent rule concepts. First off, before I even look at the problem, I see that I'm dividing two exponential equations, so I'm thinking of this rule, a to the m divided by a to the n is a to the m minus n. So before I even really do much here, I'm going to go ahead and take this expression. Again, I haven't even read the question yet. And I'm just going to write this as x to the a squared minus b squared. And again, without reading the question at all, I'm looking at this, well, wait, that's another special factor. Just like we talked about over here. So difference of squares is another one. So again, I haven't even read the question yet, but I know this is x to the a plus b, a minus b. Now, I can at least look at the question. Now, some of this is already listed up there, but they're telling you a plus b is 2, so what is a minus b? Well, hey, look, those are the factors I have already, and I haven't even done anything yet to the problem. I mean, I guess I've done some work, but now that I've read it, this is already set up. So this is going to be x, and now a plus b is 2, so this is now a minus b. So now I have that as my exponent. I was able to plug in that value. So anyway, they're telling you all this just to get you to the point that this expression that you have is equal to x to the 16th. So this equals, and by the way, this is this, so I've simplified it. This equals x to the 16th. So now that we know all this, now I can take my exponents, and I can say 2 times a minus b is equal to 16. Well, if I divide by 2, I get a minus b is equal to 8. And that's what they wanted. They wanted a minus b. So in this case, a minus b is 8, which is a. So that's going to be number 7. And lastly, we have number 8. So this one that gives you an equation, n times a equals 360. Now, if I see that, I'm probably thinking polynomials because that's, again, I know the sum of the angles in a polynomial add up to 360. So normally what you would do is you would take the number of sides times the measure of each exterior angle, and that's going to equal 360. So again, I'm probably seeing that equation. I don't want to write that down until I've read it, like what the n and the a mean, but I think I already know. So the measure a in degrees of an exterior angle, so there we go. This is literally just the equation for the sum of exterior angles of a polygon. So this is the exterior angle measure. And this is going to be, I mean, you can say the number of exterior angles and the number of sides. So they're going to say a is in degrees of the so the measure a in degrees of an exterior angle of a regular polygon is related to the number of sides n. So this one tells you we have n sides. So The number of sides times the measure of each exterior angle is always going to equal 360, always. So anyway, if the measure of an exterior angle of a polygon is greater than 50 degrees, what is the greatest number of sides it can have? So what I want to do, they say the measure is greater than 50. So what I want to do is, hey, let's plug in 50 and let's just see where that starting point is. So I'm going to call this A 50. So I'm going to go n times 50 equals 360. Now remember, we're on section 3. We don't have calculators, so when I divide by 50, again, we want to kind of get a decimal version or as close as we can on this. So I'm going to cancel out this, and I'm going to go and cancel out a factor of 10 over here. It does make this a little easier to do. So n is equal to 36 over 5. So I can tell right now, 5 goes into 36 7 times. So this would be 7 1/5, because 5 times 7 is 35. So it gets me right close to 36, not quite there. So there's 1/5 left over, which is going to equal 7.2. So that's what the number of sides would be if my angle is 50. Now, the bigger the exterior angle gets, what should happen, and you can plug in a bigger number. Let's say I plugged in 180, for example. This is just a quick example. If I said n times 180 equals 360. Well, in this case, n would equal 2. So you notice the bigger A gets, the smaller my number of sides becomes. So if I want to find the greatest number of sides, well, this is 7.2, and that's the smallest angle I can plug in for A. So as A gets bigger, this number is going to go down. So what's the first whole number you get? Because again, you can't have half of a side or a piece of a side. Well, the next whole number you're going to get is 7. So that means I'm just going to round this down to 7 sides, and 7 sides is going to equal C. So in this case, C is the greatest number of sides that I can have in this scenario. So that's going to be number 8 for section 3 from test 2.